Lesson 10.1, first lesson of chapter 10, and now we're going to be dealing with quadratic functions. So up until now we've only dealt with linear functions, such as the case y equals 3x plus 2. So whatever x is, every single time it's just going to be multiplied by 3 and you're going to add 2 to it. So it's going to always just have a steady incline of what it is. Well, when you start dealing with quadratic, which basically means you have a squared in there. Whenever you have that squared in there, it kind of throws things off a little bit, and that things happen faster, or in some cases slower, depending on what the coefficient is in front of it. So let's look at the first example here. If we talk about a quadratic function, like y equals x squared, we had a parent equation before, and now we have a parent quadratic function. So this is just the basic one of what it looks like every time. Okay. Notice here, though, that squared, yes, it's all the positives, but even whenever you square a negative, remember, it goes positive too, which is what gives you this other half of this figure right here. And we're no longer dealing with lines, we're dealing with parabolas. No, they're not parabolas, and I know that's what people call them, but it's a parabola. So this is what we got, y equals x squared. So there are a couple things that we need to know about this. One, it does have a vertex. Okay, vertex of a parabola is going to be, in this case, the minimum point that we have here. What is the bottom? The lowest, or if it's flipped upside down, let's say it takes this shape, then in that case this is going to be the maximum value. That's the highest point that it is. So just depending on what shape it is. So that's the vertex. Also has an axis of symmetry. Like if I take this, and because they are symmetrical, because they're being squared, you can draw a line right down the middle, and you've got half on one side, half on another. So those are some key points that we need to know about parabolas. So let's look at example 1. Maybe. All right. So in order to graph a y equals ax squared, so in order to graph a quadratic function, we are going to make a table, just like we always make a table. So if we put, now they've got 5 points here. I would suggest you doing 5 points only because if we do a 0, at least for today, that's going to be our vertex, right? That's going to be where we're going to start. And then if you've got a point on this side, you're probably going to have a matching point, especially if you do like 1 and 1, sorry, 1 and negative 1, or if you do 2 and negative 2, only because they change so fast. Kind of like whenever we were doing exponential growth and exponential decay. And I told you that if you just graph like 3 points, you may get to here, but then you don't really know what this looks like. So just try and graph some, I would say at least 5, so that way you can get a good picture of what it looks like. And make sure whenever you graph it that it follows like a steady pattern, right? It's not going to just have something that kind of goes in and then back out. That's not how they look. So make sure that they're not necessarily straight lines like a V. They do have to have a curve to them, but they do need to have a nice steady curve to them. All right, so if I just plot my points, put in negative 2, negative 1, 0, 1, 2, I'm going to take this function and I'm going to substitute in my value for x and see my resulting value. If I put in a negative 2 squared is 4, 4 times 3, 12. Put in a negative 1. Negative 1 squared is 1 times 3, 3. So I would do that for all these. I'm going to get these points, negative 2, 12, negative 2, 12, negative 1, 3, 0, 0, 1, 3, 2, 12. And you just plot them and connect them, and you've just graphed a parabola. Let's see what we got on the next one. Okay, this time, whereas in the last one, this number right here was a 3, right? Now it's a negative 1/4. So first of all, let's talk about a couple different things. If you have, this is the basic parent quadratic function, Okay, so they're all going to look like that in some form. This number in front of here, right now there's nothing there, so you assume it's a 1. Okay, if you have like a whole number there, say like the last one we just did was that. That just means if the parent one looks like this, then this one is just going to happen that much faster, so it's going to be that much more narrow. If I've got one, let's say is a fraction, 1/2 x squared, then that means it's going to happen half as fast, and it might look a little wider even than the parent function. Now these are pretty crude drawings here, but that's exactly what it looks like. So the bigger the number here, the narrower the parabola. The smaller the number, the wider parabola. So if I had something like 1/10, it may even look something out like that. Okay? Now, when I say smaller, I do not mean positive and negative. I just mean like the absolute value of that number. Negative, we'll flip it down. Okay? So it will take a basic 1/4, plot those in there, but it will flip everything down because that negative makes the values negative. Where before, whenever you square it, everything's going to be positive. Well, now if you square a number and multiply it by 1/4, okay, great, but then if you multiply it by the half as well, it just takes all of these corresponding values and make them negative, except for 0, of course. So I would still plug in my numbers. I'd put in a -4. -4 squared is 16. 1/4 of that is 4, but it's negative. That's the reason why that's a -4. So for x, -4, 1, 2, 3, 4, y, -4. So you see how much wider this is right here, and that's not because it's a negative, but because you got a 1/4 right there. The negative flips the parabola down. Okay, moving on to the next one. X squared plus 5. So if I were to mark out, just for a minute, this part of it, and it's y equals x squared, that would look like the regular parabola, the parent equation, right? Parent quadratic function. But because it has that plus 5 on the end, what that does is it just takes the parabola and it moves every point up 5 times. Okay, so if it was right here, it would move it up 1, 2, 3, 4, 5. Every point is just going to be moved up 5. So that's what this adding on the end did. Now you could probably guess if it said something like -3, then it would take every point here and move it down 1, 2, 3. Take this point and move it down 1, 2, 3. So your parabola would start to look something like this, where it would just start lower. Okay, so the number in front of the x dictates how wide or narrow the parabola is. The number being added on the end will dictate how far up or down the y-axis that you go. So, looking at this right here, yes, you will make a chart, just like we have a million times, and do this. But notice that it doesn't have anything being added right here, so it's going to start at 0. And because it's negative, it will go down. Okay, and this 4 right here probably, even instead of that, probably means it's going to be a fairly narrow graph. Okay, this one, positive, so it will go up, and it's a 1/3, so it will happen wider than the parent one. So it may even look something like that. And this one is going to be the exact parent equation, exact parent quadratic equation, quadratic function right there, but you're just going to take everything and move it up 2. So it would take this blue line right here, this blue parabola, and move everything up 1, 2. That is my new vertex. Move this one up 1, 2. Move this one up 1. Oh, started there. Move it up 1, 2. So we've got a parabola that looks something like that. All right. Okay, now they're just taking the two and putting them together. Still the same thing. You would still make your graph, still make your chart for all of that. Okay, but here's what you would expect. without even making the table, without doing all this, I should be able to look at this right here and say, okay, it's a -4. That means that I'm going to start 4 units down. And because it's a positive number, my parabola should be facing up. And because this number right here is less than 1, my parabola should be wider because it's happening slower. The increase on both sides happening slower than this. Okay? So it should be wider than the parent function. Now, on your homework, it's just going to ask you to graph them, and that's fine. I'm not asking you to necessarily explain or compare them to the parent function, but I just want you to be aware of what we got going on here. So this one right here should start 6 units down, should be narrower than the parent because that's bigger than 1. This one should be 1 unit up, and because it's a -5, it should face down, and because that is a number bigger than 1, even though it's negative, that 5 makes it very narrow. So it would look something like this red one right here. This one would start 2 units down because that is a negative. And because this number right here is less than 1, it should be narrower than this parent equation. So it might look something like this, only 2 units down. Okay, so this is a good graph right here to come back and refer to, even though it may look like gibberish with all this kind of stuff up here. Here's basically what you've got to know. The red one is if the number's bigger than 1. Okay, the one in front of the x squared. If that one's bigger than 1, it will be narrower. If it's between 0 and 1, so in other words, a fraction, it will be wider. If it is if it is negative, it will go down. It will be the same one as up here, only just flipped, like a mirror image, like a reflection over the x. And then the last thing, if it has a plus or a minus on the end, it takes the exact equation that it would have, or the exact parabola, and just shift it up or shift it down compared to what we've got. Okay, that's a lot to digest, and it's a lot different than what we've done before, and you've probably never heard, seen, or even said the word parabola before, but I think you'll get it. You'll be fine. So, as always, come see me if you have questions.